All right, so we're looking at this twin primes problem in while loops, and we've got this statement: the twin prime conjecture is a theory in which there are an infinite number of pairs of primes that differ by 2. So we're considering, 5 and 7. Those are twin primes. 3 and 5. The fifth twin prime pair is 29 and 31, right? So what we're looking for here is writing a function that finds the nth twin prime pair. The first twin prime pair would be 3 and 5. The second twin prime pair would be 5 and 7. And, apparently the fifth is 29, 31. So what do we need to solve this function? We're going to need a few things. One thing we want to figure out is, well, how do we determine if a number is prime? Well, we can do that pretty easily. We can say, we can write a function called isPrime, right? And isPrime is going to take some number. And we can say if the number is less than 2 or the modulus of that number by 2 is 0, then we know it's not prime. Right? 1 is not considered a prime number. Negative numbers are not considered prime. And we just cover those cases when we do that. All right, so if the number is 2, then we can return true. 2 is a prime number, but it's also, well, I just like covering the space. I think logically it's kind of nice. And then I can say for divisor in range, and we'll start at 3, right? We've already covered even numbers. And we can go up to, well, let's say we can go up to the number, right? So we're going to start at 3, then 5, then 7. We can check all the odd numbers starting from 3 up until, but of course not including the number. And if the number is evenly divisible by the divisor, then we can return false. Otherwise, we can return true. So let's check this. So let's print isPrime of, let's do 29. And that should return true. Let me make sure that this is not going to fail. I'll just put a pass in here. All right. So I'm going to run Python. So true. Our isPrime of 29 is true. And I'm just going to improve this slightly. I'm going to say that the number, let's see, the square root of this number plus 1. So I believe this is just a subtle optimization. Is that how we want to do that? Yeah, I think that should work. Oh. There we go. Oh, that's a float. I'm going to convert that to an integer. And that just reduces the number space for us. So let's test that with some other numbers. Let's test it with 27. 27 is not prime. Let's do 121. 121 is also not prime. So why don't I do this? I think this is kind of a nice way to do this. If you really want to visually check this, we can say for num in range, and let's do 2 to 2000. And let's say if isPrime of num. If that number is prime, let's print it. And this will get us better verification, right? And 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43. This looks like a good list of prime numbers to me. Okay, so spent a little time on that. but it's important to verify that your function is working as expected. Okay, so when we're thinking about prime pairs, we're thinking about a prime and the next prime. So I'm going to write a function called next prime. And this is just going to get us the next prime number. So the next prime of the number, I'm going to say the number to check. I'm going to start checking at num plus 1, right? So the next number, literally the next number. So if I put in 2, the next number I'm going to check is 3. And I'm going to say while is prime, okay, of the number to check, as long as that number is false, so here I'm using a while loop, then I'm going to say number to check is going to get incremented by 1. Okay. I could optimize this slightly. I could make it so that there's a little bit of logic to account for evens, because we should never really need to check evens. And I could do something like that with a for loop. I would more likely use a for loop in this case, but you know, I would have to write some logic to determine a reasonable max number of steps away from the current number, right? Like, can we confidently say that out of the infinite spaces for primes that we're never going to encounter greater than 100,000 values between one prime and another prime? I'm not sure. I actually have a video on windows of primes if to analyze that sort of thing. But in general, we could use a for loop, and I would probably just put 500 in there. I doubt we're going to exceed 500 anytime soon. Okay, just to be eyeballing it. Okay, so let's return the number to check, right? And let's test this. So if I put in, I'm going to say for num in range, let's just do 100. I think that's fine. We're going to print the next prime of that number. And so if we throw 0 in here, we would expect to see 2. And let's just find out if that's what happens. Because we're starting at 0 and we're ending at 99. So let's see if the logic here is sound. Oh, we actually skip 2. Why do we skip 2 if num is 2? We start at 1. And while is prime of the number to check is false. Huh. Oh, I see. I see why this wouldn't work for 2. I'm just going to throw just a snippet of logic in here to get around it. So if num is 2, let's just return 3. Let's see if that gets us around it. It doesn't. Oh, of course it doesn't. So let's say if num to check is 2, let's return 3. Let's find out if that gives us a 2 at the beginning. Interesting. Okay, well, num to check, num plus 1. So if we're putting in 0, then the first number we check is 1. And if num to check is 2, we return 3. But it's not, so while is prime, num to check of 1 should be false. When we increment it to 2, is prime of 2 should be true. If num is 2, return true. Let me just double check. Is prime of 2. Make sure I'm not missing something here. I'm getting a false for is prime of 2. So if num is 2, I should return... Yep. I should have just tested this a little bit more. I was checking 2 is obviously divisible by 2. That's why I was returning false here. Silly logical error. corrected it. Now I'm getting is prime of 2 is true. Okay. Anyway, let's look at this next prime. And let's look at this. So 2, 3, 3, 5, 5, 7, 7, 11, 11. So we're essentially getting only prime numbers out of this, which is what we'd expect. So we're checking the next prime for every number between 0 and 100, and this works generally. We don't have to put a prime in for next prime. We don't have to say next prime of some prime number in order to get the next prime. We can put any number in there and get the next prime. So now we've got the tools that we need, or two tools that we can use to find the nth pair of twin primes. All right, so let's write another function, just a quick one. Let's check if a number is a twin prime, right? Let's say is twin prime, and this is going to be num1 and num2, okay? And if num2 minus num1 equals 2, right? That's our twin prime. Then we can return true. Otherwise, we return false. Now, I'm actually going to invert this a little bit. Well, I'm going to add just another qualifier in here. If num1, if is prime, right? If is prime of num1, or if that's true, or if is, I'm sorry, is false, or is prime of num2 is false, then we can return false. Now, this is a little bit of redundant checking, but you know, we don't want to, at some point if we accidentally throw in, say, 7 and 9, if we only had this logic between 27 and 29, num2 minus num1, right? 9 minus 7 is 2, but 9 is not a prime number. So I'm just trying to be honest with my function definition here, is twin prime. I just want to be honest with what this function is doing. Okay, so let's go ahead and write this twin prime function. We're trying to get the a value out of this that is a pair, right? We're returning the nth pair of twin primes in the form of a list, right? And we want to input the value n, right? So if we put in 5, we should expect to get 29, 31 in a list. Okay. So I'm going to say, I'm just going to do this in a fairly straightforward way to try to make it simple enough to understand. In case, just so, you know, because there are very clean ways to do this, I'm going to make it just a little bit messy, but I think it'll be understandable. So we have a twin prime counter, and then we have a number to check, right? And we're going to start this at 2, okay? And if the nth, right, that nth number, like if it's the 5th number, the 4th, or the 3rd, if this is 1, if we're looking for the first twin primes, let's just return our first twin primes, which are 3 and 5. So that just, this makes it a little bit easier to write this function. We just get sort of the first value out of the way. And then I'm going to write a while loop, although I don't necessarily need to. I'm going to write a while loop here that is going to be, well, let's say our next prime value is going to be the next prime from our number to check, right? So number to check is, yeah, so we're going to essentially get the next prime from where we are. All right, and if is twin prime of the number to check and the next prime value, then our twin prime counter, right, our nth number, is going to be incremented by 1. And we can say if the twin prime counter is equal to the nth value, right, because that's what we're looking for, then we can just return this list. I would normally do this as a tuple, but it's asking for a list. So this is going to be number to check and the next prime value. And then I just need to increment, sorry, I need to take the number to check, right? And replace it with the next prime value. Notice we're not checking every number. We're only checking primes against their next primes. We're not making a sort of counter that checks 4 and 16 and all of these numbers. Okay, so let's test this out. We know that for the fifth prime, we're supposed to get. Well, I erased the doc string. We're supposed to get 29 and 31, I believe. So let's see if that's actually what we get. We do. We get 29 and 31. So I'm going to just write one more thing. This is kind of a fun thing that you can do, right? So let's say for I in range, let's look at the first 100 twin primes. Let's just print the twin prime of I. Oh, I may have asked this to do something that is a bit extreme. I think let me kill that, and let's dial this back to let's dial it back to 10. Just look at the first 10 twin primes. Oh. Do I have an infinite loop here? I don't think I do. Let's look at the first 6, because maybe maybe the next twin primes are just really far up there, or maybe I do have an infinite loop. Huh. Leave my logic here is sound. Oh, okay. We're starting at 0. So that's a little bit nonsensical, I think. There we go. It was just that I was starting my range at 0. Let's try up to 20 and see what that gets us. Excellent. Okay. So let me just do something. Let me resize my window and run that again. So here are our first 19 twin primes. So let's try this. Let's try this out. I'm going to copy all this code, and let's see if it passes our tests. I suspect it will. Yeah, and that did. Really quick, let me just snag this other code, the solution, the example solution that's in there, and let's look at it. Let's look at it. It's going to be a little bit different, of course. So here's our twin prime. It's going to use a next prime function that, if you look at this, our next prime function is just a couple things. We already have that logic, but we spread it across a couple more functions, right? And this check twin primes is twin prime function that we wrote up here is encompassed in this logic on line 81. But at the end of the day, this is basically doing the same thing. It's using a prime 1 and prime 2. I think what we did up here was, what was it? It was next prime val and number to check. So yeah, hope that's helpful. Let me know if you have any questions on that.